Hello, everybody. Welcome to Rocket Lasso Off the Record. Still moving some things around. I sound like I got something stuck in my throat. Excuse me. Hey there. Do we have anybody hanging out yet? It says 7 watching. Zach has said hello. Hi, everybody. Let me think. I'll lower the resolution here. I don't need to be playing the video at full. I can see everything on YouTube. This is YouTube only, of course, and this time I made sure that it is not accidentally public. So last time I was like, wow, we have a lot of people showing up. And it was like, oh, wait, it was accidentally public. Tobias, hi there. How's it going? I try to think if there's anything to cover, but I think we can start diving right in. Does anybody have any, I don't know, like specific questions before I get into the focus topic of today? I tend to try and do very simple answers if anybody has that type of question. But we'll be playing with connectors today. I'm seeing if I can get the chat to pop out because I see everybody's message on my second monitor if it's closer to the first. I have to separate the monitors a little extra distance for this because the camera is in between the two monitors, not above it, like your typical webcam. There we go. Pete, hello. Good morning to you. It's 2 o'clock here. Yesterday we found out, at least I found out, I didn't know that you can use, with Dynamics we use connectors, but I found out you can connect a connector directly to a connector. So today is trying to figure that out, learn how that works, and some of the possible ramifications of it, because there's a lot of pretty cool advanced rigs I think we can make if we can start connecting connectors to connectors. But what I really want to see is if we can connect connectors to connectors to connectors, like a chain of 3, because I think once you have a chain of 3, you can do pretty much anything. But yeah, we'll have to find out. I don't know how. I never knew this. But in any case, let's just jump into cinema. Oh, I guess one quick thing to cover from yesterday is somebody in the chat yesterday, Jason, sent me an email talking about that there was a way of doing this rig we were trying to do yesterday. There's a way of doing it, and he just said the word inheritance, and he had a whole paragraph. I was like, oh, inheritance! I didn't even think about that. And it doesn't refresh. Oh wait, this is that's not the proper one. Here we go. So there we go. We've got this shape, and now you can see it's pretty much the same hierarchy we had last time, except instead of a plane effector, we're using an inheritance effector. And when I play, I now was able to pretty trivially keyframe all of them in order and choose all their positions and everything, and everything's very automatic. So I'm not sure if there's any kind of proper follow-up because that's, it's a little specific to make a tutorial, but it's pretty cool. I sent Jason the email. I just wanted to see what his screen name was so I could give him credit for giving me the pointer on that. And I was going to post it on Slack, at least this updated scene file. And this updated scene file will be included in the scene files. So whenever I work on something after the stream ends, I always say, I'll put the number in there and I'll say post stream. So a neat little additional detail. But yeah, it totally works. And it's not terribly difficult to add more layers onto it. And it's entirely parametric. In fact, Jason was talking about putting limitations on it using MoGraph selections, but I was able to make it work with the linear field. So pretty cool. Yeah, excellent. So for the proper follow-up on yesterday, let's start playing with connectors. I actually don't have too much in the way of specific plans here. There's going to be more about figuring out how they connect. So we'll just start building some rigs. So let's begin. Let's begin with I guess we'll do a square because why not? That should be clean. And I'll put it into a null. This null will go -100. Put this into the null. I'm going to use signal just to get some automatic, very controlled motion from the rotation. And we'll put a noise on there. Signal, of course, is a plugin developed by Grayscale Gorilla. Well, by me when I was at Grayscale Gorilla. Hit play, and we're going to let this start rotating. Oh, I forgot. There's a bug in R21. and we hit compensated for it. If you try and drag a vector in the signal, it doesn't work. Usually it would, but we can force it to work by holding down shift, and that will actually turn it into a vector. So redragging it on there, you can see that it is a vector. So I can say 90 degrees, 90 degrees, 90 degrees, and I can see this can rotate real crazy all over the place. More frames, please. 999. Very fast, so 0.2 for the speed, and different random seed. Let's go a little far. 45 degrees, double the speed. So very inclined to tilt over that way. Strange. Oh, the base is bent. There we go. All right, so now a very controlled cube wiggling around in the center point, and we'll turn that into a collider body. Oh, we have to do the old thing, but it makes it signals. Well, here's another reason why signal is great. If we're going to do dynamics, we need to be 0, 0, 0 at the beginning. Now, if we did we'd have to keyframe other things, but with signal, I can go into the noise tab, twirl down advanced strength over time, and just drag this down. It's going to start at 0, and over the course of 90 frames, transition into all of that motion. So I'm going to say, let's transition in over the course of 30 frames. So that should start out at 0 now. Nice and simple. Okay, cool. So this becomes a collider body simulation, collider body. And now we need to start, now we want to make connections on top. So we'll make it very clear what's happening by creating a cylinder, make it thin. It's nice to see some heavy contrasting colors here. So I will make a green one. Let's make a orangey one. We'll probably need it, so I'll just make a third one, which will be nice dark blue. All right, so the cylinder is here. I'm going to move it 200 units up in the air. We can see very clearly where it is, what it's doing. It is going to become a simulation rigid body. Exactly, Tobias. Step 1, connect connectors to connectors. Step 2, question mark. Step 3, profit. Or at least maybe get some cool ideas and or tutorials out of it. All right, so that's now dynamic. This is wiggling around. This should just kind of instantly fall over. Pretty much what we're expecting. So we'll save that into episode 7, scene files. Connectors. All right, so number 1 version, really straightforward. Let's create one of those plane connections because I'd never really used those. Dynamics, connector, move it up 200 units. Actually, I think it's only 100 units. There we go, right on the ground. Change the type to planar, and that just means it moves in 2 directions on the plane. Turn on limits here. And they should all be 100, totaling up to 200 in each direction. So there's this weird, it's strange the way the box cuts off. You can't see there is a shape there. I don't know, I don't have a very, very good intuition for how this moves around. But by taking this, making a child of the cube, and then connecting from the base to the cylinder, base, I can call it base 1, and then this could be cylinder 2. Just by doing that, that should mean that this is stuck vertically and it can slide around the surface. So I've never really used this, but there you go. See, it's working perfectly. This is now connected. Now I will go back to, I guess that this slides itself back and forth. It's just strange to me the way you would think that that box would end on the edge, but that's not the case. So it's just all part of the way they built the widget. But it's cool. You can see it sliding around. It's free to slide around all over the place and just catch on the edges and stay vertical. So that's cool. Never used it. Never really had much of a use for it. This is a very specific type of motion, but good to know. Now, let's make it. Well, what we were doing before is there was like a gravity that was pulling this upward. And I think that's probably a good idea. So I'm going to do that again. So I'm going to hit Control D. And we're going to invert gravity. And then we've got this connector, but, and you know what, just let's be real clean with it. I'm gonna hit save because this is a fine, clean setup. Simulate, we'll just create a new one from scratch. So we're gonna make a second connector. Now I think if we're gonna do an order of operations, first that connector happens and then this one does. So what is this one gonna do? Well, this one is going to be a ball, ball and socket. So it's just free to rotate all over the place. I can move it up to 100 units, so it's right at 0. So what I want this to do is connect to that connector. And you can see instantly it gets highlighted in spite of it not being selected. So I think that's a good sign. And then that is going to connect to the cylinder. So this is now automatically fixed it. You see that when one connector connects to another, it automatically updates itself. So that's a good detail. It's good to know. So now there should be a full-on option for this to rotate right there. So it's going to be stuck to the surface, but it can now tilt and rotate around. And then gravity is negative. Yeah, gravity is negative. So it's trying to push itself upward. And there we go. That is seemingly working perfectly. Yeah, this is now free to roam around the surface. And gravity is saying, oh, no, but you want to keep going upward. You want to keep going up. So, you know, we did this yesterday. We had 2 connections going and the 2 were working fine. Now, that's really cool. This opens up a lot of possibilities. And even yesterday, I was going to try and make essentially this effect happen, but I was going to do it by putting like an extra dynamic object in between to kind of be like an invisible connection. And now we can do this directly. So yeah, that's neat. Good to see. So, you know, this basic version is something we had no idea we could do is working. Save it again. We're going to be very organized here. If something's working, we're going to save it. Connect connectors. 2 connections. We'll use the word connectors some more. Hey, Dean, thanks for making it. If anybody's hanging out in the chat and you haven't and you're hearing me, just do a quick shout out so I know you're here. Even though I can see how many people are hanging out. It's good to see who's here specifically. It's saying there's 10 people here. Okay, so there we go. That's 2 connections. Now, the next step I would like to do is see if we can, what I tried to do yesterday, and that is see if we can get this one to spin. Can we make a 3rd connection in a row? That's a good question. And I want to make it a little bit more obvious. Now we saw that this connection is working really well. Let's try switching instead of this connector like this, I'm going to make a slider connection. And we're going to rotate it upward. And this one can only travel up and down. And I'm going to limit this one as well to 100 units. Actually, we can start from 100. So I'm going to start from there. So it can start at 0 and travel up 100 units. Now, all that should happen right now is gravity. What should happen is this can freely move around forward and back, left and right. And then it's going to suddenly shoot upward 100 units because that's how far it can go. And it won't rotate anymore because the slider does not enable that. Now, that broke right away. That's interesting. We only still have 2 connections. Now, is that negative? Depending on the way I rotated this, that might be positive. So let's do positive and negative. Nope, still broke. Interesting. Don't limit. Still broke. Okay, when in doubt, simplify. I'm going to turn off that first one. Let's start at the base. Connect to the cylinder. So now it should be forced to go wherever the cylinder goes, but it's going to move upward a little bit. So yeah, it's going to move upward. So that is working correctly. Let's turn on some limits. And then now it's not traveling upward at all. But if that's pivoting from center of mass, that's interesting. Let's try increasing this amount. Okay, well, yeah, you see, as I increase the amount, then now it moved. So in spite of it being set at 100, it wasn't far enough up. It wasn't up enough, so let's keep that in mind. So let's try turning on the first connector. So the second one is now connecting to that one. Instantly, it's breaking everything. As I imagine it's still broken. Now, can we increase this amount? Still broken. It's going minus. Set that to 0. Interesting. It's not, I don't think I'm doing anything wrong. But it doesn't like a slider connected to a slider, which is strange. Now, having said that, I mean, there is a different type here where it's the box one, which also has that verticalness. So maybe it doesn't let you do these two connections, because we could have done the same effect with a single one. But immediately we're hitting an interesting limitation, which I'm not sure why. All right, so back again, we've got our basic connector. Let's say that this is connected again. This should be back to where we had started. It can slide on the surface. Now, what I'd like to do is make it so that this connector can spin, because right now we are limited to these axes. Actually, we can even simplify it some more. If I change this to a single slider, this can only move on one axis. It's only going to tilt, it's only going to slide one way and the other, which is nice. It's a rail. So if it's on that, can we create a connector before it? And this connector is going to be a hinge. This is what we tried to do yesterday, and it seemingly didn't work. So if I spin that vertically, and let's keep it basic again, just for testing. Pace 1 to cylinder 2, turn off this connector. So now, actually, we're not really seeing anything, but this is now stuck on. Actually, we were seeing this a little bit yesterday. Do you see the? Do you see how the? It's like this connect, see, that is stuck properly. But see how this connector is moving around very strangely. I don't understand why it's pivoting off of its center point like that. I don't trust it. I do not trust that. Why would it do that? You can pull it out of the hierarchy entirely. And does it, yeah, see, that is still moving around. Now, is that just signal? I doubt it, but let's bake signal. So on signal, output, keyframe, convert to keyframes. So now everything's grayed out. It's just keyframes. Yeah, see, it's not signal doing that. And then order of operations. Cinema calculates from top to bottom. So we can move that down. But that doesn't change this from moving around, which is interesting. The attachment is the center of mass. It's very strange. If I change the displayed mode here, you might see that this is, in theory, it is rotating, but it doesn't have much motivation to rotate. You can see the axis here actually is rotating a little bit. So I don't know why that's sliding around. I can't think of any reason why it would. If it's inside the hierarchy or if it's not, I'll try making a child cylinder, but I don't think that'll change anything. Damn. So very strange. I mean, these are the only ones I can think to change, and I don't think that would have any effect, no. So why doesn't it follow it around? It seems very odd to me, but well, let's see. I don't. It seems the end result is working correctly, but it's not giving very good visual feedback. I don't know why. So let's try and connect the connection. So those are directly connecting. I grab this connector and say, you're not actually connected to the cylinder, you're connected to that connector. And then that connector should connect actually from the base to the cylinder. I think that's the order we want. So we have, this one when we, okay. So from the base to the connector, and then from the connector to the cylinder. So straightforward enough. That's odd. I told it to always display, but it's not displaying it. Strange again. They're not actually, they don't display at all when I select them. So the only way we're going to get, that's definitely weird. The only way we're going to get feedback is just seeing it the way this moves. And it just flies away. So not so nice there. Try making them not children. Well, apparently making it a connection to a connector is stopping it from displaying. If I clear it, well, that's weird. We're definitely in an area where it's not used very often because this is already behaving strangely and not intuitively, but it's more that it's not seemingly not refreshing properly because I just kind of clicked and then clicked off and it refreshed and suddenly it is displaying it. Let me see if the same. Oh, now I don't know. That happened. This is connecting. What did I just do? Because suddenly the order of connections is all messed up. Yeah, okay, this connects to that connector. And if I click back on this, it's the top one that's connected. So I should be able to change the bottom one out, I think. Still flies away. Now it's not displaying it again. Now let's see if I click that and click off. No, it doesn't refresh that time. If I clear, it does come back. If I drag it back in, it's still there. If I click off and back, it's still there. This connection, it did refeed it here, so maybe it wants the bottom one. Oh, interesting. So they're just seemingly displaying, if I do the proper order, it seems like I dropped the wrong one in. So a good methodology here might be clear them out when I make a connection and then see which one it automatically built the connection in. So let's hit play and see what happens. All right. That is, it's crazy, but it's working. So I thought that, does that make sense? Yeah, that's free to move that way, and it's free to move back. Now, for all purposes, if I deselect this, this should, I mean, it should be free to go back in the center, but its speed is so fast that it's always staying on the end. It's never, it's by the very nature of this type of connection. Yeah, I guess it does occasionally. It will slide back in, but you see, most of the time, the centripetal force is keeping it kind of plastered on the edge, but occasionally it does move back in. One of the, I'll say, problems is that there's no bounce to. Oh, wait, there's a bounce. Oh, tell a lie. There we go. Now there's a bounce to it. So if it hits the edge, it'll bounce. I was gonna say there's no bounce to it. So now that is going. That's weird. I'm gonna rewind, but that seemed to escape its confines. Bounce, bounce. Maybe I click some. No, as it spins, you see it goes further and further, and it's escaping. Is it going further and further and further, or it seems to have gone a set distance too far and is not going any further? But I could be wrong. It's hard to see. But why does it eventually escape its limitation? I mean, that's not good. Let's get rid of the bounce. Okay, well, interesting. The bounce seems to be the thing that made that happen. Whoa, whoa, whoa. See, this doesn't ever seem to escape the cube. As soon as I had some bounce, it did. Let's try a lower bounce. Bunk, bunk, bunk. It's like getting out of control. Jump it up to 55. Bounce, bounce, bounce. Now, it's never quite getting to the point where it's like super centripetal on the edge and spinning around and around. But even at 55, it's not escape. Whoop, here we go. Whoa, whoa. Yeah, now it is escaping. Once it got to the edge, I almost feel like that's got nothing to do with bounce. Bounce was just making it more likely to get there. Although if I get rid of bounce, you see it instantly jumps back to being locked in. Now, in any case, this is doing a good job. It's trapped in that. Now, I wonder if, I don't think it actually helps anything, but we can change this to a planar based one, and it's still trapped inside here, but it just can move on all the axis. So it can spin. Interesting. This is not behaving the way I thought it would. But if that's the, it's free to move around. It's moving the opposite. Maybe I have to change the order, but because it's like, it's behaving as if the center point is on the cylinder, and then the edge connection is on the pivot. So this is not necessarily, well, maybe it's an order of operations thing. So like we said before, let's clear these out. And then inside of this connector, we'll clear that. And I'm going to reverse the order. So I'm going to drag that in and then make sure the connection hasn't been made. And then drag the second connector in here, there. And now let's see how this one said. It said, okay, I'm connected here. That's fair enough. Drag the cylinder in. And I just reversed the order of them. So let's see if it feels a little bit more like that this 0 point is stuck here. And yeah, you see how this is stuck in the middle of that pillar? So that change of operation seems to make this behave a little bit more. And now this is stuck in a spinning rectangle. So it's going to be able to escape the bounds of this box a little bit, but that makes sense because we'd need to, in order to properly limit, we'd probably have to do some pi-based math. But visually, you'll see what the problem is keep in mind that we're not looking at the edge here. We're looking at the little edge here. If we move, let's just eyeball. I'm going to make a copy of the cylinder. I want to see this as well. Always display. So if I grab the cylinder and I say, okay, scoot to the edge that you can there, and then we need to scoot to the edge here. That's fine. But then imagine that this thing is spinning. It's able to spin. So at that point, it would be like creating a null at the center point. And if I spin that null, you'll see that that can travel outside that. So that's kind of the limitation there. We need to pull it in about that amount to emulate the same circular potential motion. But without having this cylinder, we're not trapped in a circle. We're trapped in a unmoving square. So a square that can spin is the same as being in a circle by my estimation. So, I mean, we can just eyeball that by, I suppose I could just hit T for scale. Yeah, I'll just scale that in a little bit. And I think that, yeah, well, it depends on the scale I moved it to. Maybe it's still not quite enough. Yeah, a lot closer. So that should be trapped more. Yeah, you can see right there. That's almost at the extreme. So trapped a lot more. Still not quite small enough. But you got to keep in mind it's like double the length of this. So I wonder if that would work. I'm going to, for fun, if we put a null, create a null, I'm going to put it right about here. Can I make this a child? And rename it and make a tracer. And that's going to trace a line, but it's going to trace it in world space. So there is a line, but you see it's moving all over the place. But if I were to make the tracer a child of the rotating null, does that move it in relative position? Yes, it does. Excellent. So now you can see that we can see the entire path it traveled. And there you go. Now we get you see that little twirl of a traced out circle. And we're not necessarily at the extreme placements that can go, but that's, it's pretty consistent. Although I will say it's not absolute. It's does seem to have a little bit of play in it, but at the same time, you gotta keep in mind that these connectors the connectors are not absolute. It puts in like force restrictions, but they can definitely escape. So as another means of testing, you saw the way that tracer was tracing the line, and very quickly it's going to start spinning, and the spin is not super accurate. There's a lot of variation there. Now that might be fine, but let's try cranking up our steps per frame. Let's make it 3 times as many. Let's go even 4 times as many steps per frame and see if this is a more accurate circle. Generically, I'm not. It doesn't look more accurate. Now, is that just the course of it wiggling around? Are we still bouncing? There is, oh, interesting. There is no bounce. That's why I didn't think there was a bounce. There is no bounce in the 2-dimensional one. Interesting. All right. Well, that's all good. And I like this tracer. It gives us good feedback. Now, we learned a little bit about the way the order that these connect. So let's try pushing it a little bit further again. A connection we already saw was working very nicely. I feel confident to just take one and modify it, clear them entirely out. And we're going to switch this to the ball and socket. So this connector, which can freely spin and rotate, is going to be attempting to connect back to the cylinder, but to the connector 2. Cool. And now in the connector 2, you can see that that's taking up this spot. So let's try putting in the cylinder. And it should be always on. Now, the other ones disappeared, which is making me think they're not going to work. Interesting. If they disappear, they're not working. So that one worked, and then that connected to here. That seemed to work. So this is a connector connecting to a connector. This connector is a ball and socket that should be able to freely move around. And it's connected to cylinder 2. That's all correct. And it just doesn't work. But let's try tweaking it from both directions. I'm going to grab this connector. Instead of being connected to the spinning one, let's try connecting the base. Boom, both of these appear. And that can now tilt and move around. Okay, so that was one test to see if there's two connections instead of 3. And now we'll come out from the other direction where we'll go back to this connector. It's not even silly to do, but if we go back to this connector and connect it directly to the cylinder, then boom, they both appear again as well. So what this is implying is you can connect a connector to a connector, but you can't put a third one because going from here and here forward worked. Going from here to here works. Going from, so every combination of these 3 does work unless all 3 are connected in sequence, and that does not work. Hey, Sam, thanks for making it. Did you put a link, Zach? I can't see the link if you put the link. If the link doesn't show up here in YouTube, although I think it would work, if it doesn't work, put it in the Patreon Slack channel, and I'll put it in the Patreon Slack channel and tell me that you did, and I'll go click the link over there. Okay, so so we're seeing potentially a limitation on that. It just doesn't seem to like a third connection. Having said that, I wonder now if I could do the connection I was going to try and do yesterday, like a fake connection, because this only will go 1 layer deep on connecting connectors. So if I were to do that, what would I do? So that didn't work. A, B, C, D. Okay, so what I would do is make some other object. In this case, I'll make a sphere. Move it up 100 units, so it's right in that point right here. So, okay, it's a little too small, so I'll go here. Make a dark blue, just so that we have some colors. And, okay, and now we make this like a dummy connection. So I'm going to put it here, and I wonder how far we can go with it. I don't know. So I will make it, let's start out by just making it dynamic. But when these connections are made, they're going to turn in, it's going to say, hey, ignore the collisions with other objects. So, but this will be trying to not collide with that. So we'll have to keep that in mind. But We could scoot it in the air potentially. But in any case, I'm going to say that this connector can connect not to the cylinder, but to the sphere. So I think that will just fall away. I'll turn this off. The cylinder will fall away and our sphere will travel the surface. It is not. And that's because it's not dynamic, so we'll make it dynamic. So there we go. Now this can travel along the surface just like the cylinder had been. So fine, good enough, fair enough. So now we've got this new connector. So that new connector, I want to say, hey, you are connecting from that little sphere to the cylinder. So it's now become a bridge. So now we have a complex connection going to a cylinder, which resets everything, going to a simple connection. So it might be a little twitchy, but let's see if, okay, yeah. So, but this, there could be friction in the system here because you see that's not moving. That could make sense. So here's a thought. I'm going to take the cylinder and shrink it a little bit. So we'll just go 190. So it's a little shorter on both ends. So that means it's a little shorter still, 175. So it's a little shorter, which means it shouldn't be directly connecting. I don't think it's going to snap into place. And now, yeah, there we go. You see the cylinder is quite a little bit smaller. So using this intermediary step does work. So even though we can directly connect the connector to a connector, which is a sensical sentence. It's neat we can do that. I'm glad we can, but we can always use this dummy in between. Let me rename it dummy. This is the dummy in between that is now enabling this to swirl around, and it has the ability to introduce the next level, which is now this tilting. Boing, boing, boing. There's something in Unity, the video game engine, where you can tell things to be on different layers of dynamics, and that would be really cool in cinema. In fact, that'd be a great note to give to Max on. I should say that. Make layers of dynamics like Unity. You never know when they might have a chance to implement something, but I don't mind giving them suggestions. So what's happening is this cylinder, well, there is this connector is saying to connect the cylinder to the other object. The point being is, with this bridge in between, this object is not ignoring this object, which means they collide with each other. And if we didn't want them to collide with each other, I don't think there's no like this, you'd have to bake one dynamic system. There's no like dynamic system level number where you say these are twos collide with twos, twos don't collide with threes. So there is none of that. Now, having said that, I do have an idea, which could be weird. Let's see if this works. I don't know if it'll work, but it'll be fun if it did. I'll make a new connector. Simulate dynamics connector. And I'm going to move it down here. I'll even make it a child of the dummy. That's fine. And we're going to change this to a fixed type of connection. It is going to connect the dummy to the base. Now, if we hit play, it's just going to be stuck there. And that's just the dummy. Oh, wait, I'm doing this wrong. It shouldn't be the dummy. I want to put this in the cylinder. So it's supposed to be the cylinder to the base. So now that should be stuck to it. And you see it's not really going to move. I mean, there's that little dynamic imperfection where it could move a little bit, but there's a fixed connection. But now this is saying to ignore the collisions. Zach, I see that you have linked in to the Slack, so I'll click that in a moment. So you see that those are now connected, and now that they're connected, you can see they're ignoring collisions. Now here's where my question is. I'm gonna hit save. If I turn on braking force, this is at what point will it break this connection? When a connection is broken, does it continue to ignore the connection? Or when you break a connection, does it ignore the collision? So if the force is at 0, then that means it should break right away. So it should just go like instant break. And now that's broken, and it did break successfully, which is good. We need to see if this is going to fall through the box. Negative gravity is too strong. It's never going to quite, well, maybe it will eventually if it got the perfect angle, but I'm going to lower gravity. Let's go gravity 0. Oh, it worked. Haha. Okay, so we've got a trick. We have a trick now to use fixed connectors to say this object should ignore that object. So now, and actually that's a useful tip across the board. I should make a note of that as well. I got to start making notes for presentations. Fixed a broken, that's a weird way to say it, but a broken fixed connector is a way to make two dynamic objects ignore each other. I might put that in the tips and tricks video in the future. Okay, yeah, so this is a connector that is merely existing to say, hey, you two are related now, so ignore each other. So it's a good solid workaround for what I was describing. So this is now trapped inside of a spinning cardan on side of a plane that can now spin in every direction and is going to ignore the object that we've been colliding with. And now we can reset this back to its default height, and it'll be just passing through, assuming our dummy object was not supposed to be visible. And if I make all of our connectors not visible, then this cylinder is just kind of stuck. Its middle point is stuck on the surface, and it will move around and create little scribbles and swing. I mean, honestly, if you told me that this was a dynamic setup here, I'd be like, I don't understand that you could not do this simple thing that we have here. So we'll save that. Two connections plus dummy for, we're gonna get nuts with names, for third. Okay, neat. All right, let's click on Zach's link. It's so YouTube isn't letting you put a link in. Let me see if there's a setting. Manage moderation, participants. If I put a link in, does it work? Let's see. www.rocketlassoslack.com. Does that link come through, and does it work as a link? It's weird it highlights the name. But you can't put a link? Well, in any case, I'm gonna click your link. So you got James Nolan Gandy. It looks like is it physical or is it? It looks physical, yeah. And it is 90 minutes and 6 different pens. So let's see what we get here. Whoa, time lapse. Is there any audio? I can't hear. I got a copyright hit. No, there's no audio I can tell. One of the videos that popped up when me and Amador were talking hit me, so I can't monetize that video because it got copyright claimed. Now this is cool, but one of the problems is it's going so fast that I don't know how we built it. It's neat. Oh, okay. So here's another one. Okay, so he's just got some different rotating cylinders, and yeah, we could totally build some rigs like this. Oh yeah, those were multiple stories. How do we? There we go. Nice. Whoa, we make some very advanced ones. That's cool. I understand completely the principles that are happening here. It just goes to, well, a lot of these you can see the different layers of string. So these are all sorts of gearing ratios to eventually make one thing turn and spin. from two different handles. But at the end of the day, I think it's just two cylinders spinning, and then you can get incredibly complex combinations when you have two cylinders on top of each other. But yeah, very nice link. Okay. We could build something like that, but that's not using, I don't really think that's using any new concepts. Those are just straight up, those would just be straight up regular connections, Cardan connections, or hinge connections, not Cardan. Cardan's a double one. Those would be straight up hinge connections. So I'm just trying to think of other things to test here. Now that we have the better order of operations, I'm going to disable the dummy and the rotation, and we'll connect directly to the cylinder. But so yeah, this is going to be free to spin but stay vertical. We saw that it wasn't working with a connector with a connector. I'm going to try it again because our order of operations might have been wrong, and I just want to confirm it. So we will begin with this planar connection, which means we will start on, and we'll clear these out. Clear, clear. We go to the first one, and we're going to connect, clear, clear. I'm going to connect to the base, and the second object will be this connector. Click on that connector, and I'm going to say, hey, you're not a hinge, you're a slider. And that will now connect directly to the cylinder, which should be free to move up and down. So if we play, nope, it turns red right away. So this is we just did the very clean version. I'm going to turn off the fixed connector, but I don't think that'll do anything. It does, like putting it looks like not every connector will connect to every other connector because we did this correct. That was very straightforward. I'm going to turn off the limits because you never know if something might introduce. Nope, still broken. This one, still broken. Now, like I said, it's a little redundant to do this setup, but it just goes to having more control. The reason it's redundant is that we can have what do they call it? A box slider, so you can trap something within the confines of a box. But that's too bad. It just makes it so we don't know what other connections might not work. What's cool though is like based on some of the very basics here, you can trap all sorts of things in all sorts of ways. Like we can do this planar. Actually, you don't even need a planar. We could make this a slider with limits. And this base isn't even of consequence. I'm not worried about it. And then its second connection here could be, oh wait, no, sorry. The first one is a ball and socket with no limitations. And the second one is going to be a regular slider that is not rotated with limits. And now this combination, putting it into a ball and socket instead of a hinge, means that this should be able to spin in every orientation. And then the slider will be the result, which means the pivot point of this connector is going to be a circle. It can travel the outside of a circle. So if I hide the box, I think if we let this tracer, is the main thing we're concerned with here. This tracer, yeah, it's doing it pretty much perfectly. This can freely move on the surface and the interior of a sphere. So we can create all sorts of limitations. Now, obviously, this is a silly way of going about doing this in this instance because you could just trap it inside of a sphere and it wouldn't matter. But the idea that this can freely move around the confines of a sphere is pretty neat. The point being is there's a lot of like primitive shapes and things like cylinders, squares, circles, spheres, cubes. These are all shapes that we can think of. Like these are tools to put into our mind to be like, oh, we can trap things within these spaces using connections instead of trapping them inside of like invisible other shapes. And it's important to do that if you're not going to let something rotate. We told this one that's free to rotate, but you could trap like a cylinder inside of a cylinder. Yeah, that's a good example. This is perhaps a little silly, but let's say for some reason we want to trap a cylinder inside of a cylinder and have it be able to freely move within that. So here's our secondary cylinder. we'll make it not show up. So render tags, oh yeah, I did the right one. Display, use display line. So now we can see through it. And then, you know, I'm going to delete that for just a moment and save this as a sphere. Connect connectors to connectors. Sphere. Trapped in sphere. All right. Okay, now I'll paste that back in. That becomes our new base. So we don't actually need that base anymore. And this cylinder, I don't need effects. I'm going to simplify a little bit. We'll zero this out. So that's trapped in there. Now, if we just made this dynamic and said that it could freely travel inside here, like, yes, it would move, but it would tilt all over the place. So how do you stop it from being able to rotate? Now, you could really lock down its follow rotation, but that's only trying to return it to its rotation. So with that in mind, we have not a cardan. Let's put this back to a hinge, and now that can spin, and that should be pretty much it. We just need this to connect to the cylinder, and we don't need dummy. We'll have this connect to cylinder 2, which is perfect. So with any luck, this it is tilting. Oh, this is not rotated the correct orientation. There we go. There. Now you see, now it's locked. Now it's freely moving around inside there, but it cannot rotate. And that is a definite difference. Now, if we can also make it move up and down by, this is the cylinder, or this is the slider type, but let's try putting it to the box type, make sure that works. And let's limit the top and bottom. I mean, honestly, we don't even, if we could still limit it to this plane, it can still freely move here, but based on that connection, we do need both of these. And now we just make this a collider body. So I'm going to say that this is a moving mesh. Yeah, so we can actually see the inside of it. There's some bounce, there's some friction. So if I play, we're trapped inside. I mean, these sliders are allowing it to freely move inside of it, but not rotate. And it hasn't gotten there yet, but there's no limitations, right? Yeah, there's no limiters. So, oh wait, and currently it's ignoring collisions. So let's make sure we're not ignoring collisions because we want them to collide. There's nothing. Is there no gravity? Yeah, I got rid of gravity, so there's no reason for it to. Yeah, there's no reason for it to move. In fact, for a little bit of simplification, I'm going to unbake that, not make it rotate. So now it should just be static. Nothing's going to happen. And now we created turbulence. Particle turbulence 55. Give it a little scale. Hit play, and now you can see that our little cylinder wants to move around all over the place, but it cannot rotate. Now there is that little bit of tolerance where it's going to be stuck, but it cannot rotate. It's trapped within the bounds of this cylinder, and it can't escape. It would be a good idea to click on the cylinder and say that it is I don't know if this will work fully, but I'm going to say a Y-based cylinder. Yeah, it won't work because it's not seeing the inside, so that's unfortunate. So if you want this to go a little smoother, get rid of those segments and increase the ones on the outside. And it's quite bouncy, which is fine. But I'm going to get rid of the bounce and the friction. So this is just freely kind of sliding around inside of it. Bunk, 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 bunk. And yeah, no rotation. So this spinning actually isn't even necessary. Now that I think about it, we just needed this connector. So it's able to rotate, but I don't think that makes a difference. It's not making it any worse. But for the sake of simplification, let's delete that one and just connect that cylinder 2 to cylinder base. And there we go. This is a simplified version. So this connection is just going to follow it around, but now it does not have the ability to rotate. Bunk, bunk, bunk. And then, I mean, where this gets interesting, let's see if it'll work. I don't know if it will, but I'm going to make this a child of the cylinder. And does it move around still properly? Yeah, it's not rotating, so I think that works. I don't need the tracer right now. So let's decrease. Let's make this not be automatic. We're going to set that to a Y-based cylinder. So that should be very clean calculations. And then get rid of extra polygons that we don't need. And now we got that cylinder trapped inside of a cylinder. And you know, we can just change this shape because it can infinitely move around there. But let's see if this works. What could be neat here? Trapped in cylinder, not rotating, which is interesting. I mean, stylistically, that's the important part here. But I think based on this rig, we could make a cloner and clone a bunch of these. So let's see. If we want to put as many as possible, we want to make it a honeycomb, flat on the ground. The distance between each is going to be pretty small. I'm not sure exactly, so we'll say 5 by 5. It's per step, so if I separate these, separate those, separate these. There we go. They're not quite colliding. And if we trap these inside of a circle, then now we get a circle shape, and we can make as many of them as we want. And they should be, well, you know, eventually they'll escape, but this is kind of packing in as many as we can. I think that'll do. So let's just see if this works. We shouldn't even need to make it editable. And these are all now trapped inside, but they're not allowed to rotate. They can spin, but they can't. I don't, actually, to tell you the truth, now that we changed this connector type, they might not be able to spin either. I'm not sure. So it's interesting how you can see the scale of turbulence with these types of clean rigs. Now there's a lot of visual kind of neat possibilities. If you were to ask me how to do it, I would have, you know, it wouldn't have been obvious. Let's try 15 by 15. That's about right. That's close. 22 by 22. There we go. Now we can make bink, 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 and then go bink, 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 bink. Actually, these can also be cylindrical. And then I can make a few more. Yeah. So you do that, and then we can add some vertical ones. And let's make there be more. And then not quite that, and not quite as tall. So we'll shrink the individual ones down. Oh, I moved the cylinder. That's why I'm tripping over it. Yep. Okay, do something like that. You get these cool little shapes. And now these should all be doing the same thing. They each have their own connection. They can't spin. They can't move. Yeah. So this is not lack of rotation. This is not being forced to not rotate. And now we can visually, you know, we're just getting kind of a cool looking lava lamp type of thing. We might even be able to say these are multi-instances. No, you can't do multi-instance. Multi-instance breaks the connector. And so that's what we end up with there. But if it is an instance, then, and we rewind, then they're stuck vertically. That's pretty neat. If you were to, we've actually done this before where we were trying really hard not to let things rotate. And I didn't think about this connector. It's an important additional detail. I'm just going to lower the point count on them a little bit just to make them run a little bit faster, because I'm going to be slowing it down quite a bit by making this many of them. And it does have to make each connector, which is slower still. It's hard to tell if they're spinning or not. I don't think they are. Yeah, that's neat. That is neat. I like it. Let's add a bunch of bounce. No friction. Boing, 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 boing. Dangerous thing you do is give it above 100% bounce, and then the energy starts being additive. Now, this doesn't seem too crazy, but it could slowly start introducing more and more energy into the system to the point where they will escape. Just a lot of basic fun to be had here. Get rid of all of the friction, add in a little bit of drag. That should make them very responsive to the force. Yeah, if you had asked me how to do this a week ago, I would have said to just use a really heavy follow position, but that there you still get some tilt out of it. And I think we even built a rig. We built a rig last year. I was trying to do that, and what we did is we put a really heavy angle, and then we used espresso or a connector to make a copy of it follow itself with no rotation. So one was approximate, and then it would mimic it. But now this should be pretty much forcing it to perfectly be aligned. And actually, why don't we try and rebuild the rig? If I'm remembering correctly. I'll save that. We'll start from scratch. The basic idea was we had a box display lines. Then inside of the box, I'm gonna steal the colors from here. Bink. Inside of the box, we had a series of boxes that were constantly changing scale. So let's see. This is going to be a simulation collider body, off, shape, static mesh. This one is going to be a simulation rigid body, and it's way too big. We're gonna make these pretty small, so I'm gonna say 20 by 20 by 20, and pretty straightforward. The same connector. I like doing this manually because every time you do something, you're making another copy in your brain. You're reinforcing it. So we could copy and paste a lot of things, but I want to remember the behaviors of these connectors. And if I want the behaviors to be stuck in my head, I need to lock them in. Now, I think I need to lock them in and copy them by making more and more and more of them. Finishing a thought. So I'm going to link this to the box. So it should be not rotating. It's just going to move. And I'm not going to link something to the second one, which should make it run just a little bit faster. Yeah, because it can't rotate just based on that. Bunk. Yeah. So now that goes into a cloner. Do a grid. Per step is just fine. Let's put these 30 by 30, a little bit of space between them. No, let's do 22. Just a little bit of space. Something like that. And now gravity is turned on, so they'll all fall to the ground. Boom. And they're there. But they cannot rotate. And what makes them not rotating interesting is if we add a plane effector. And the plane effector is controlling the scale in a not uniform way. I want there to be a lot of scaling here. Do we need the, oh yeah, min and max. So I want to go up and down. I guess we could use a random effector, but I like using plane. So if I say negative, does that? So that happens. And now we put the fall off. I give it a random field inside there. It's got a noise, but I actually don't want it to be noise. Let's say random. No, it has to be noise based, but it's noise based on randomized sample position. I'm not so sure about that. Getting a little got a little crazy there, but let's increase that. So there, yeah, now they should be scaling. Okay, neat. Okay, that's almost immediately working the way I wanted to. So they're going to be kind of trapped in there. But as they change scale, gravity will take over, and now they can fall, but they're changing their scale, and they do seem to be going up and down. So good job, plane effector. Let's start pushing it further. There's probably too many, or we're scaling too much. And we got to do a lot of things, but yeah, they're never going to want to go downward. Is there anything that might make sense? We might be able to make an entire little world here. That could be kind of cool. I'm going to increase their habitat. Let's go up to 300 by 300. And yeah, there you go. They scale, and now they're going to be scaling up and down. I would love this to be more extreme, but they don't. A normal random could be, yeah, you see absolute doesn't mean anything here. And I'm curious if this negative is even doing anything. Yeah, it's not. Now, that might have to do with clamping. If I unclamp it. No, it's still not doing anything. So that just means to me that we do want a plane effector. Let's make sure these don't turn off. 0, 0. We do want a random effector. Every once in a while, it still is useful. And this goes to negative 100 as well. So don't affect the position, but yes, affect the scale. Do not do it uniformly. Say 1, 1, 1. So there we go. Now you can see that they're very, very random, and they're not square anymore. So the plane effector was not cooperating. I'm going to say indexed. And that should actually, yeah, we're going to say that I want this based on noise. So now they should be changing. But if we set them to indexed, then they should each independently be getting their own noise. The default speed, it does have a default speed. I'm going to say UV based. That way it's going to be based on, if the cube moves, it follows it. If you say global, then they pass through the noise. I don't want them to pass through the noise. So this is noise based, and it is going, and the scale is affected. So now let's double that. Now I think based on what we did, they can go inverted. They can actually like invert because it's doubling the amount. I just want heavy contrast where they can really scale up. So that what I might want to do is say that they can only go absolute, which means they only ever go up. And that just means we start out really small. So start by like 1, 1, 1, and now they're all really tiny. But the random scale is going to be doing it in a uniform way. So I can say I want these to go up to 20 times their scale. And actually, you probably want to go up to like 50 times their scale. So it can go anywhere from 1 to 50. There we go. So those are looking good. And now they never go negative because they're an absolute scale. You see they're all scaling, doing their thing. And I'll tell you the truth, they're still not that big. So I'm going to go up to 100. Nice. Yep, they're doing their thing. They're going to bump each other out of the way, but they cannot rotate. Now, let's kill off the friction. No friction. Let's even say no bounce. It should be nice and buttery smooth. And in fact, if we want buttery smooth, we can do damping, but I've been kind of a fan of drag lately. So let's, I got a lot of drag. So now there's so much drag in there that they're only going to move if something else is pushing it out of the way. So if we've got this many rectangles that cannot, these cannot, I completely lost my train of thought because I'm trying to think like 2 steps ahead. So these are just going to be gravity fed, so they fall down. Why don't we turn off gravity just as a fun way to start this out? So no gravity, so that means they're just going to be pushing each other out of the way, and eventually they'll push each other all out of the way so that they'll never really touch. So that's probably right around now what they've done. What I would kind of like to do is make it so if they were a particular scale, they would move up and whatnot, or like, I know there's a lot of different things. We can make them all attracted. Let's make a field force. I'm trying to think of like what I'm actually trying to achieve here, and I'm not sure. So let's make a field force, and we can just create a spherical field inside of it, and this should be like a big attractor. So yeah, you can see that right there. Strength 55. And it's much too small. And before I even change the scale, I don't want this remapping. So I want full power all the time. So full power, no fall off. And now increase the radius. So it's only going to show the little increase there. Now you see it's actually pushing them all out to the side. That's because we need to invert the direction. There. Now they should get they're going to get a, no, that seems to still be pushing them out. Invert direction. There we go. Oh, that's weird. They seem to be doing the opposite of what I wanted them to do. But now I know what they're doing, so I'm going to turn off the display box. And now, are they shoving each other out of the way? Why do they Okay, that's weird. Look, why do it feel like it's attracting them all inward? Like it does feel like they're getting attracted in. At a certain point, they suddenly like go out to the edge and it's like they're getting pushed away. Like, look, what is even happening? I mean, honestly, we don't even need this box right now. These should just be anywhere getting pulled. So that feels like they're getting pushed away. The field force is adding to velocity. I'm going to say absolute velocity. So this is constant. So this is applying a constant force, a constant speed. What is happening? Invert direction. Now that you can see they're getting attracted. So, okay, I said invert and now they're getting attracted. But if I rewind, that's pushing them out. What is I don't even understand what's happening there. Is there something I'm not thinking of? Like, yeah, if I turn these off, they're just doing their thing. Get pulled in the center, please. And then how long until they're pulled in the center that they're just gonna be like, nope, let's invert polarity again. And they do, look. They start traveling away again. That just makes no sense to me whatsoever. Why is, I mean, that's not even supposed to be the point of this. I mean, just because I just don't want to deal with it. That's such a tiny detail. I hate using the attractor. The attractor's the worst. Yeah, the attractor does all sorts of goofy things. I don't want to use the attractor. So I feel like they forced me into using 4 different types of wind. They forced me into it. But it's tried and true. You can see that this wind will blow everything over. Oh, interesting. The wind is based on, look at this. Look at the way that they're moving. And they stop. And they go, and they stop. One thing that's happening, and actually this is kind of adorable, I didn't even think about it, is the drag. When they become really skinny, the drag is blowing them. It suddenly can blow them away. And when it's fat, it can't. And when it's skinny, it can. So that's a funny detail that the drag is doing that. I don't want that to be a variable right now, so we're going to turn off the drag. And now you're going to see they're all move at constant speed. Now, I wonder to what degree the drag was being affected by, I'm going to hit undo. To what degree was our field force getting affected by the drag? So we'll zero out the drag again. I still don't trust it, but yeah, they're all getting attracted here. And now let's see if they still decide to invert. Now, the next thing I was going to do is change their mass. So I'm going to give them a custom density of, well, it's 0. I'm just going to give them a custom mass. So they all weigh the same amount. We can even say a mass of 0. So let's see if that will change something. I mean, it's so weird that they're attracted. And at a certain point, they're just like, nope, I'm not attracted anymore. I'm going to start wandering away. I can't fathom what's happening on that. It could have something to do with the connector. I'm going to actually turn off the connector and see what happens. They're all going to be fight to get in the center. And then at a certain point, they just wander away. I can't even fathom what's going on here. When in doubt on this kind of weirdness is just copy everything and paste into a new file. And all we have to do is turn off gravity. I mean, it's almost acting as if everything was only calculating the first 90 frames. And after the first 3 seconds, it would change its behavior. But nothing here should be, oh, it's still doing it. It's like this field force or something is keyframed and it's being told like, oh, at the time of 90, you're suddenly different. I mean, you can so clearly see it here. They're all attracted. And then right there at 90 frames, they start wandering away. I don't like calling out bug because I could have always done something wrong. But that's the correlation I'm seeing right now is at that time, it suddenly starts wandering away. So I don't know what to say. Let's go. We were going to try and start doing it with wind. We'll go back to trying to do it with wind because I just want to see if I can make something neat here. So I'm going to go back to a very simple version. Wind blows forward, and it should always blow forward. Thank you very much. Fall off, linear. Linear fall off. It should be facing on Z+. So let's see. That means we want actually Z-. Mink. So the more back they are, the more power they should have getting flung forward. And then by the time they get a certain amount, they're going to not be getting more speed. That's the theory there. So if this linear goes backward, let's say 100. That's nice. These front ones, yeah, you see those front ones weren't pushed until they were bumped by something else. Okay, that's nice and simple. So then all I'm going to do, I think these did start working inside of cloners. I'm not sure, so let's try. I'm going to make a cube. I'm going to put the wind into a cloner, and then the cloner is going to be told to clone onto an object. The object is going to be this cube. And now you can see it makes a bunch of different ones. I'm going to say I want the polygon center, and now you can see there's a wind on the center point of each of these. It looks like they might be spun backwards. I'm going to spin them 180. And the cube should be really tiny. I'm going to go 1 by 1 by 1. And let's see if that works while it's inside of a cloner. As these pieces float, if it's working, as these pieces float away, they're going to get blown back towards the center. It's possible I do have it flipped 180. And it's possible that my linear field is backwards. So let's get rid of that 180. And that seems worse. Maybe. It's hard to tell. How strong is the wind? It's very weak. 55. I think my linear field must be backwards. Z+. I mean, it does seem to be working inside of the cloner, but it's not working at all. What is happening? I don't understand. Our dynamics have lost their minds. Oh, they're really, really teeny weeny. Yeah, they are. But why are they not moving? They're not moving because they're outside of the linear field. They'll be inside the linear field if this goes down to 1 by 1 by 1. They get blown away, which means the wind is backwards. So now they get blown away if I spin it or if I don't spin it. Is the 180 not doing what I think it is? Oh, it totally is doing what I think it is. None of the other ones are going to change it. Oh my goodness. What is even happening? This is simple. I feel like I'm doing something. What is even happening? All right, I don't trust anything that's happening. We're starting from scratch because I like this very basic idea. I don't even think it's that fancy. I just think it'll look nice. So there we go. Material, cube. Cube, 1 by 1 by 1. It is orange. All right, that is going inside of a cloner. Hello, cloner. That is now going to separate out via a grid by a spacing of 2 by 2 by 2. And now we will make it 15 by 15 by 1. And now we've got this cute little grid. All right. Everything's very small. That's fine. So turn off gravity. Control D. Go away, gravity. You know what I should also do? Is restart cinema. Could have a weird cinema hiccup. I have had that happen. But let's move forward with this one. If I play, nothing should happen. They're not even dynamic, so obviously nothing will happen. Simulation, rigid body. Hit play, nothing happens. That's correct. Now, don't turn off dynamics. Don't turn off. All right, attractor, a very basic attractor using the new field forces. Field force, hello. Spherical field, cool. Spherical field has maximum angle. You know what? Just for fun, I'm going to drop it down to 99%. Remember we were talking about the linear field, and when it was at 0, it stopped working? Well, I'm going to go on the same theory here. Let's say if it has no offset, then it can't figure out the transition. I don't actually believe that, but hey, let's eliminate variables. So if I play, boom, everything gets attracted in. If we leave it playing, it's twisting around. That's fine. That makes sense. So that's all good. But now if we increase our time, are they going to start floating away? For no good reason. They are still all clumped together. Excellent. Cool. That's what we want. Let's increase the strength, 55. So now they're very powerful here. Now, if they're going to spin, they could potentially escape a little bit. But that is 55 is not too much. Okay, so yeah, we're doing that. They'll all get pulled in. Excellent. Now, next step. I'm going to... We'll just do it again from scratch. It doesn't take long. Random effector. They're all really tiny, so the random effector is going to affect the scale in a not uniform way, and I want these to be able to get really big, so let's set it to 50 by 50 by 50. They can really scale up. So, and I want it to be absolute because they can only get bigger, not smaller. And just for sanity, why don't we add a signal tag so that this is a strength of 0 to 100% over 90 frames, so they'll scale into their first position. So we've got a big old spherical thing that's going to try and keep them trapped in here. Now, if they get outside of that radius, then they're going to escape. Why don't we make the scale this not quite as big? We'll keep it easy, 15 by 15 by 15. Play. So they're going to get bigger, but not so big. And there we go. The attractor is still, yeah, it does escape eventually, but let's just increase the size of that. 1,000. I don't think that should change anything. Now you see they get pulled back in. Cool. They're all getting attracted back to the center. It's behaving the way it should, like the very basic field force should. Let's save it. No rotation. All right. So fine. That's all good. This is behaving the way we wanted to. Those are all scaling, doing their own thing. Now, the random, we want it to animate. So we do that by setting it to noise. It's got a global speed or a global position. I don't care about that. I want UV. I want the animation speed to be nice and slow. And then we're going to set the index so they each independently do their thing. Hit play. Now it should do this, but they're each going to be changing. Oh, okay. Interesting. Now introducing that is making them fly away. What part of that made them fly away? Let's go back to global. See if that changes anything. No. Let's try turning off indexed. Interesting. It's not good because that doesn't make any sense to me. Why these being a noise is making them fly away. Now, let's make the assumption that there's a problem with the random effector. Let's try applying this with a plane effector instead. So I'm going to say plane effector. We're going to do pretty much the exact same rig. Let's control the strength of it. Yeah, that's controlling the strength of it. And this is going to do the same thing. It's going to, I guess they'll be uniform. We'd have to do one for X, Y, and Z separately, but let's do an absolute scale. Scale out of 15 by 15 by 15. And now they're all going to be scaling up with the plane effector, but they haven't shot all over the place. But the other one didn't shoot all over the place until we gave it noise. So inside of the fall off, we will give it a noise, a random field. But by default, that's already doing its thing. If I animate it, weird, look at that. As soon as it's being fed in the exact same way, if it's being fed an animated noise, they fly away. I don't understand. Why would that happen? Custom mass 0. Still fly away. Custom mass 1. Still fly away. It does not like the random field. Now, is it just the act of them animating? Because they scale up with signal. So let's try feeding it a shader field. The shader field will have a noise. And that's, they're all randomly shader fielded, but let's make that have some speed. That is not flying away. It's a little hard to tell if it's, yeah, that should, bink, 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 bink. Now these are unfortunately probably each passing through. Are they passing through the cloud of noise? But they should be animating. It's hard to tell. I don't see any one of them animating. All right, when in doubt, start cranking. Oh, every time I change it, oh. We have to turn on frame. It's not refreshing. Okay, well, they are animating, and then they fly away. Let's have it be slower. It's animating, but slowly. And they fly away. It can't handle the field force, and it's not even the field force. I feel like the regular wind was doing the same thing. It can't handle an animated noise affecting the scale. I don't know if it has to be explicitly the scale. Let's find out. Well, I mean, scale is the only thing that can be affected here because it's not following the position. Well, this is disappointing. I don't understand. What could possibly cause that? I'm glad we started entirely from scratch because I wouldn't be trusting the results from all the different things we did. Actually, look, this is extra interesting. This is currently not affecting anything. Look, we are feeding in a sphere, a shader field, and they all fly away. But the shader field isn't driving any parameter inside of the plane effector. You can see that we have a no position, no scale, no rotation, no color, nothing. Now, if we delete that, no, it does. No. See that it still exploded, but it's not going to infinitely fly away. I'm not sure why it exploded. It could just be that they all have a lot of power built up there, but they're not flying away. Let's try adding some drag. Drag is doing surprisingly little. Drag might be a function of density. Yeah, it is. So putting density back up, the drag will suddenly have a very big effect. Whee. And there could just be a lot of, that's still a little weird to me. This could be just a lot of tension there. But that doesn't change anything really, because as soon as we start feeding this something that animates, I think it's going to break it. So we turn that on. It's fine. These are all going to grow. I think we should end up with kind of the same result. They're mostly escaping. Make that bigger. Yeah, there's that initial one and they all explode, but oh no, they are still escaping now. Oh man, this just got weird. This wasn't even the point of this. I don't think it's even. Let's see, what can we do? This isn't limited to field forces. Even that's still odd. Look at the they grow and then they suddenly explode. The only thing happening right now is they're being told to grow in an absolute way. But there's no friction. There's no. Why do they do that? There's no forces here. Why are they doing this? And there's a ton of drag. And even this is still swirling around as if we saw the entire other setup. I mean, honestly, I just don't trust anything. I'm going to close cinema. And reopen it. It's taking its sweet time. There we go. It is opening in the other window. All right. Well, let's just open up that same scene file and see if we get the same visual result. Yeah, still explodes. We still are going to have one swirling around it for no good reason. And all the rest are flying away, as far as I can tell, for no good reason. Signal is doing that transition of strength. Let's eliminate that as a variable at time 0. Record. Give it 100 frames-ish. Strength 100. Hit play. They're really tiny. They're going to scale up and then explode. There is no gravity. There's just lots of... They do not deactivate. There's just lots of aerodynamics. The aerodynamics shouldn't have anything to do with anything. Well, this time it doesn't explode. The aerodynamics are some sort of variable on this. That's weird. But aerodynamics cares about mass, and they're changing mass, so maybe it doesn't know how to handle that. Let's go on that assumption. Based on that assumption, let's open up the previous one. And we got the random, we got the scale. Let's go. This has the big old giant attractor. It has no aerodynamics. So if this has no aerodynamics, they're still going to fly away all super crazy. They're all attracted. How is this functioning? Oh yeah, this is pre-setting the noise up. So we turn on the noise and they're going to fly away. Get rid of I've recently found out that linear and angular damping can be a detriment, so we'll get rid of that. They'll just kind of swirl around, do their thing, ignoring the field force entirely. What is even happening? See, those explode and they're just going to keep doing their thing. That's fine. That makes perfect sense to me. They're each pulsing in a very uniform way. But if we click on the random, we can say indexed. And currently they're passing through the global noise. So they're going to shimmer. But if we change it to UV, yeah, maybe that works differently than I think it does. But now they're just going to drift away. That's fine. Perfectly fine. Makes sense. Now let's say we wanted them all to stay in the middle. That shouldn't be too difficult. Back to the dynamics tag. No aerodynamics. No damping. Defaults across the board. For everything that matters. Oh boy. So this is just them flying apart because their own scale is making them fly apart. Cool, fine, whatever. Let's make a wind. I'm going to do this very manually. Simulation. Forces. Wind. This wind will blow them in that direction all the time, no matter what. Whee! Nice. All right, so then we say, I want to fall off. I want a linear fall off. I want a linear fall off on Z+. And I'm going to scoot that back. So what this is saying is Z minus. What this is saying is if you are on any part of that side of the wind, you're going to start getting blown to the right. If you're on this side of the wind, there's no more power. It's not doing anything. So it's a little bit weak. I can jump it to 55. So now when this kind of, they'll get pushed out of the way immediately, but they're not going to accelerate anymore. They've already got their speed, I think. It's hard to tell, but I think they do. All right, all good. So if I were to, let's say, move this here, that shouldn't have any effect on anything. And when those suddenly get through there, what? Yeah, even here, you can see it's not working because as soon as the randomness has gotten applied, it's going into the wind and not being affected at all. If I move this over and they are all in their original position. Okay, that's interesting. You saw even the existing ones started to move once I moved it over their original position. Yeah, sadly, Zach, it's not signal. Well, it's not signal specifically doing the ramp. Now we are ramping up. We already did the keyframed version of it. We just say full strength. Well, if we do full strength right away, it's going to explode. Boom. I wonder if that is a variable. Does it not like an animated strength in this case? So if we put a lot more space in here so it can compensate for how big these all are they free to animate after the fact? Now those, they're getting hit right away. That's because their starting point is in there. Now, if we were to move it in, does it affect it? So if I play, nothing's going to happen. They're all just doing their own little wiggle. If I move it in, the wind is moving it. Okay, so does it not like strength getting keyframed? Let's find out. Random, power of 0, time of 100, full strength. So they're all tiny. I hit play. They're all going to scale up and do their thing. Now, actually, if I move the wind in, I imagine they will move. But that's because they're all in their original position. If they were forced out of their original position, if they're overlapping each other a little bit, so let's set this down to 5 by 5. So as it ramps in, they're going to get pushed out of their original position. you see they'll drift because they've been collided with. So their origins are still in the 0, 0, 0 spot. Now, when this flies in, my assumption here is as these pieces drift in, the wind is not going to affect them. But if I were to grab the wind and scoot it over, as soon as I get past its original origin point, then they do get affected. Now, okay. Now let's not keyframe these up. They're just in their original position right away. So they should still bump and fly out of their original position. But now, when this enters the wind, no, it's still doing the same thing. When it enters the wind, they're only affected when it passes in their original axis position, not in their new up-to-date position. And that seems to have to do with the noise. So now we're on UV, or now I'm on global noise. Let's try turning off indexed. No. As soon as there's noise, it will not acknowledge them outside of their original axis. That's a big old pain. I can't do anything with this particular thing I want to build up if it won't acknowledge them except in their original position. If there's a noise being fed through the system anywhere, seemingly fields will only acknowledge them in their original position. I feel like that's a pretty fundamental problem. I feel like I would have run into that earlier in cinema, in R21, if that was the case. I feel like I'm losing my mind. Yeah, the original axis. Such a simple setup. And yeah, this is a bug file. Spherical field. Pretty much full strength. Anything that goes inside the spherical field should get blown forward. Bunch of things are going through it, has no effect because it's not in its original position. Grab this and pull it forward. And suddenly, when it passes through the original position, it does get affected. That is what we're running into. Is there any way around it? Is there any way around it? I mean, we start going into really, really goofy ways of getting around it. Let's do 2C bug for Maxon. Noise and origin. How can you make all of these oscillate offset from each other randomly on scale without using something noise-based? Literally, the only way I can think of right now would be to animate it with signal and bake it out. So like pre-cloner, we've got this cute little cube and we put a signal tag on it and we animate its size. I gotta hold down shift as I do that. And animating its size, we can go into noise and I can say I only want to go positive. I want it to go up to 15 times its length. And let's see what the speed is. It's going to tend to float in the middle zone. So I'm going to crank the bias up to 55. And it makes the bias go Really strong. It's still not wrong. It's very distinct, though. Okay, so you see it's doing its thing. The numbers are still going to tend to float in the middle. You see right here. Right here would be 0. And they're going to tend to float near the middle. It's not necessarily a problem. Let's continue the test. I will do strength over time. So the first 3 frames will slowly ease into its craziness. Ding, 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 ding. And then we shall bake it because MoGraph won't see it. So I'm going to say convert to keyframes. It shouldn't take too long. It's only 1,000 frames. And there's not a complicated scene. Okay, signal's now doing nothing. So we can make a bunch of clones of it. It's clones with 1,000 keyframes. But go away, random. You are not our friend. Okay, so these are now dynamic objects that are all going to scale up. So there's no noise involved, though. Oh, man, all those keyframes are killing it. Killing it. Yeah, you can see they're animating, and they should still be dynamic. Let's just prove the concept. So they're all going to collide with each other. Them being dynamic, they should bump each other out of... Yeah, they're going to bump each other out. Now, the question is when they pass through this wind, will they be acknowledged? Because there's no noise. It's a little hard to tell. They suddenly decided to bump in another orientation. This wind, which is quite strong, doesn't seem to be having an effect. Let's not mess around. Really strong. Still no effect. Still no effect. That was the only other way I could think to do it. Man, that's going to be real cool, and now it just doesn't work. Okay, I give up on that aspect of it. We learned some information. All I really wanted to do was this. Like, we had this really neat rig, and these were moving around doing their thing very nicely. I wanted to have them start scaling and bumping into each other as a way of fighting through and making something cool and techie looking. But as soon as we animate the scale, it can't handle it. No, the cloners weren't set to multi-instance. Because I restarted the scene like 3 different times using building from scratch. They weren't all in multi-instance. Just to confirm, open up the Max on Bug one, click on the cloner, and you see regular, not instance. Bum, bum, bum. But I just need to be sure. Yeah. Drag was freaking him out. Everything was freaking out with that. I mean, we could, this is just trapped in a cylinder, so potentially we could scale these, but kind of goes against the artistically what I wanted to do with that one. I actually had like a weird artistic-y type idea. I didn't want to do it. Random scale 1 by 1 by 1. Noise based, indexed. Don't animate too quick. Yeah, I mean, there's no field, there's no forces in here. It seems to be the actually, what seems to break it is that the fields. Fields won't acknowledge them. There's no fields involved here. But I mean, I kind of wanted them all to be clustering up and making this weird techie block thing. The lack of rotation is what was making that interesting. I'm gonna set this to be a uniform scale. Yeah. Mysteries. It's still neat. I mean, we've got some cool effects going here. We just learned something, a weird limitation when it comes to fields, which is bizarre. Well, at least we figured out it was based on the origin. Hmm. After that, my brain is kind of fried, so I got nothing's coming to mind now. Do. Cylinder. Well, yeah, one of the it just goes to the fields, the nature of the fields is the sad part there, because if I were, like I just kind of built the same rig here where they're really tiny, and I want to apply, there might not be a linear field in here, so it might not affect it. But if I were to make a plane effector, affect the scale in a uniform way, in an absolute scale, I want to go up really big, like 55. So it has a potential to get really big. Okay, cool. And now, actually, I guess there is a noise, and it doesn't like the noise. So maybe it won't work. It won't. Their original position will be what's affected. But the other one, this is just trap, so I guess it could work because it's going to be referencing their original position. So here I can make a random field. It's already got a noise. If I click randomize sample position, I think that means they get looked at different parts, but give us some noise. It should be very similar to what we were just seeing. Although it does sort of explode. Maybe it's a little too powerful. Yeah, okay, they're getting all affected a lot, but let's see. Is the noise changing the scale? Let's make them animate really fast. Yeah, they are scaling up and down. So fine, fair enough. Now it's being fed a random noise. So, the basic thing that, to start making it look a little more stylish would be remapping the strength. So we can create a curve here and make it so that most of the time they're pretty small, and only very occasionally do they get scaled up pretty big. Yeah, and the way the noise gets mapped, you got to keep in mind that noise is a grayscale image, so most of the colors are in the middle gray. Very few, if ever, does it get all the way to white or all the way to black. So you have to compensate by changing these curves, so I can make it so they're all really tiny, and occasionally they can start getting to these peak. Now, if we slow it down, so now the idea is, like, as one of them scales up, it's going to push all the other ones away. That's like one of the basic things I was trying to do. The only reason that we're not having too much trouble here is all these are referencing their original spot, and we don't have anything falling off to affect them. So, that's why we haven't broken yet. I will say it's a little bit weird. Oh, we have a turbulence still. Go away, turbulence. This is not about turbulence. It's about them bouncing into each other. Now, Bounce. Force. We got drag. No drag. No linear. I want them free to bounce around. Like when someone gets pushed, it's just going to bounce. Boing, 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 boing. Yeah, so it's cute. I mean, this is a more basic version of what I wanted to go for. We're kind of trapped in like a lava lamp type of a situation where what I wanted them was attracted to each other and not rotating. Now, they are not rotating now, which is neat. If you were just asked me how to do this before, I would have said to a very heavy follow position, but now they're locked in because of this connector. So, you know, that part of it is nice. They do have a lot of force. We wouldn't mind adding a little bit of drag. Wow, a little drag goes a long way. Oh yeah, we knew that though. 0.1. Yeah, there. So I kind of want them going slow until they get very specifically bumped. And then I would want to stylistically make it even, you know, I want them to stay pretty small most of the time, except for the occasional times when it suddenly decides to grow up. Bing, bing, bing. Yeah, we're clamping in so much that a bunch of them get to stay really tiny baby ones. Now we could scoot this up a little bit, which is odd, but that's going to increase the minimum, so I can't get that tiny. Yeah, so, you know, here's your kind of goldfish bowl version of it. Nothing is happening here except they occasionally scale up, and when they scale up, they might bump the other ones out of their way. If you want to be... It's all, this is plane effectors affecting everything in this very uniform way. And I do like them being uniform along that axis, but it would be great to copy and paste and add a second plane effector. That's fine. It's going a little nuts, but I'm going to say I don't want a uniform scale. I want... Or do we want... I think I might... no, I guess we do want this. We want one on Y. -1? Yeah, I'm not sure. -0.9. Can't get all the way skinny. Yeah, so now they're uniform, but they have the ability to be like skinnier. And then even based on the way they're scaling here, usually we would do it inside of the effector, and I guess we still could. If I grab both of them, I guess we got to do them independently. They are sharing the same random field though. I don't know if they should be. They can literally have the same one. And I like the colors that came in. They have the random field. And I was going to... What was I going to do? Oh, man. Oh, I remember. Let's put this into a group. That seems smart. Not a folder. A group. Okay, so now this is a group field. And the group field will get some delay. Yeah, there we go. That's the ticket. Springiness. Is that going to work? Doesn't feel like it's working. I'm not feeling the spring. Give me some spring. Give me some smoothing. I mean, smoothing seems to do something. The alternative here was just adding the delay effector directly. I mean, I expect this to work, but it's strange it didn't work within it. I'm only worried about scale. Spring. Give me the spring. Give me some springiness here. I'm going to say, it doesn't really feel like it's doing anything. But is it just a trick of the eye? I just can't tell. I don't know. I would think that they'd like shoot up. You know how we can force their hand inside of our remapping? Inside of the old contour, we'll just give it no transition. So there we go. Now if we see anything besides these two scales, it means it's finally working. When in doubt, force a test protocol. So you can see it's just jumping between those two states, and no matter how much... Well, you can see now you are getting these... I'm on spring mode, but it's behaving like smoothing. You see, it's not overshooting, going wobble, 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 wobble. Unless it is on the... Is it just like too sensitive? Actually, it's funny, but I am actually seeing the tiniest little bit. If it scales up, I do see a little bit of a wobble, but why is the effect so minor? These are scaling a lot. Yikes. Yikes, yikes, yikes. Well, we had a bunch of things work well. We had some things not work so well. It's just how it goes. Sometimes. I like getting some movement in here, but not too much movement. I want them to travel, but how much drag can we put in? Where, yeah, I like the beginning where it's like, oh, there's almost no movement, and then they'll bump some away. Yeah, I feel like I like a little more drag, so there's less motion except for where they are actively scaling. Yeah, giving it a little follow position just for fun. They'll constantly try to return to their original position, but keep getting bopped back out again. I mean, I don't like the idea of follow position. I like the idea of them being able to freely travel the entire thing, like slowly. One on the bottom could get all the way up to the top. Nothing stopping them from doing that. Their side-to-side motion is going to be a lot more common because they're scaling side-to-side a lot more. If I make them scale vertically, now there's going to be a lot more vertical because these can scale up and bump one vertically. Yeah, see, those are traveling way up. You know, just different styles. Personally, I kind of like them skinnier like this, but whatever. This is just a little fun exercise. Okay, well, we learned some information. The connectors were pretty straightforward. We can't connect the connector to a connector to a connector, but we can do two, and we can use a dummy object, a dummy small dynamic object to become the bridge between them. So we can make as many connections as we want. We also found out how to make something travel through. something, use a fixed connector to trick two objects to be able to pass through each other. So that's something as well. Yeah. I got a couple notes to write. There's some things I want to send the Max on, but we got some good information overall. So hopefully everything will be all good for next week, doing the regular stream and everything. I'm going on a ski trip tomorrow, over the weekend, just local. It's like 2 hours north, so heading up to Wisconsin, the Wisconsin Dells area for Snowgraph. It's really fun. It's a bunch of Chicago people going skiing. I've only gone skiing twice before on this trip, so I'm not very good at it, but I super armor up. Like I have wrist guards because I need my hands for doing my job. So we'll see how that goes. Looking forward to that. I think that'll wrap this up, though. Thanks, everybody, for coming and hanging out. As always, of course, thank you for supporting on Patreon. You wouldn't be here unless you were already supporting, so thank you so much for coming. Hopefully, you learned some extra details in here, and I'll be able to make some really cool tutorials out of the detail. That'll wrap it up. So thanks, everybody. I'll see you on Wednesday. Bye-bye.